Hey guys, this is the video that I said I was going to make about the quantum computing, this thing that I found. Okay, so quantum computing is being developed by scientists, obviously. It's not going to be developed by like athletes or anything. Um, and it's supposedly going to be, has the potential to be way faster than even today's supercomputers. And I thought I'd make a video to explain how quantum computing works since it could be part of your everyday life very soon. You know, you don't want to have it be in your cell phone and not even know how it works. Well, basically, a quantum bit, qubit, however you say it, is like a regular bit in the sense that you have zeros and ones on or off. So a regular bit can be a 0 or a 1, on or off. Those are two possible states, and it can be in one of these states at any one moment in time. So if you have 2 bits, then you can be in 4 possible states. That's 0, 0, 0, 1, 1, 0, and 1, 1. 4 possible states, and these 2 bits, these 2 transistors or whatever, can be in one out of these 4 states at any one time. And they simply cycle through those 4 states really fast to try to get their whatever they're trying to figure out. And so as you get more and more transistors and bits and whatnot, then you get super fast computers that we have today. And even the most powerful supercomputers today have to do things one at a time. They just do it really fast. They do it like one thing every few nanoseconds. And so that's where they are. And we're trying to get them to be faster, but it's getting increasingly difficult. Quantum computers, a quantum bit, qubit, can be a single qubit, can be a 0 and a 1 at the same time. That's where it differs. And so, due to this principle that an electron or a particle can be in 2 places at once, so it can be in the on position and the off position at the same time, as long as you're not observing the system, because then it collapses into a regular state, and it chooses one of them. If you just leave it alone, it'll be both of them. But if you look at it, or if something disturbs it, it'll instantly choose one of the options randomly. It's weird. Quantum mechanics is weird. So if you have 1 qubit, you can do 2 things at one time, at the same time. You know, you could be in a 0 and a 1. That's already twice as fast as just a single bit. 1 qubit is the same thing as having 2 bits, basically. Where if you add another qubit, and I have 2 qubits, I can be in 0, 0, 0, 1, 1, 0, and 1, 1, all at the same time. All 4 of those possible states simultaneously, whereas a regular classical computer operating on 2 bits would have to choose one of those at any one time and cycle between them. So if I have 10 qubits, I'm able to be in 1024, which we'll just round down to 1000, 1000 possible combinations all at the same time. If I have, for every 10 that you add, you basically multiply that by 1000. So if I have 20, I can do 1,000,000 things at once. If I have 30, I can do 1,000,000,000 things at once, you know, which is already approaching computers that we have today. You know, 1,000,000,000 things at one time, computers today can do, or 1,000,000,000 things at once, and if you do that once every second, that'd be 1,000,000,000 operations every second, about, give or take a few million operations. Regular computers nowadays, I think, can do 200 billion operations every second. So that's pretty close right there. And a qubit is the size of an atom. It is an atom. So 30 atoms isn't that big. And if you go up to 40, you'd be able to do 1,000,000,000,000 operations at the same time. And for every 10, you keep going 1,000,000,000,000, then it's a quadrillion, a quintillion, you know, basically follow the things. Kilo, mega, giga, tera, peta, and then it keeps going. So these have the potential to be super, super powerful, crazy supercomputers that we might have in the near future, within the decade. You know, so that video that I referenced this to on about the future of technology in 10 years, well, in 10 years we might have quantum computers in our everyday life. You know, our cell phones, TVs, laptops, desktops, tablets, iPods, even our gaming systems might be run using a quantum processor. So if I didn't explain it good enough, or I explained it but you just didn't understand it, or for whatever reason, um, I will try to figure out how to post a link on this thing, and to link you to other YouTube videos that explain it better than I did. So I don't know if the links are already up there. Yeah. Anyways, that's the end of the video. Post a comment about what you think, if we're gonna, how long you think it's gonna be till we have quantum computers, if we're even gonna have them. You know, because we might run into a wall when we're trying to develop them to be as fast as our today's computers. You never know. So just comment or whatever you guys do when you're watching this video. Okay.